Welcome to our journey through the fascinating world of Java, one of the most influential programming languages in the digital universe. Java's significance lies in its omnipresence, from powering small-scale applications to forming the backbone of large-scale enterprise systems. It's the magic behind a myriad of devices, a vast array of applications, and a multitude of platforms. It's the language that has been shaping our digital world since its inception in the mid-90s. In this video, we'll delve into Java's inception, its evolution, and its dynamic adaptability that has allowed it to remain relevant in an ever-changing tech landscape. We'll explore its various versions, its unique features, and the intricate workings of the Java runtime environment and the Java virtual machine. So fasten your seatbelts as we time travel through the evolution of Java. To truly appreciate Java, we need to understand the motivations that led to its creation. The inception of Java was driven by two primary motivations. The first one was the need for a platform-independent language. Back in the day, programmers had to write separate code for each operating system, which was a time-consuming and inefficient process. They wanted a language that could run on any device, regardless of the underlying operating system. This was the seed from which Java sprouted. The second motivation was the aspiration to improve upon existing programming languages. Developers were seeking a language that was not only easy to learn and use, but also robust and secure. They wanted to minimize implementation dependencies and reduce the likelihood of fatal errors. The goal was to create a language that would bring order to the chaos of the programming world, making coding more systematic and less prone to errors. Java was also designed to be a network-centric language. In the early 90s, the internet was growing exponentially, and there was a need for a language that could adapt to the evolving landscape. Java was envisioned to be a language that could easily handle the complexities of network programming and internet protocols. And the cherry on top, Java was intended to be a language that was not just for computers, but for all types of electronic devices. The vision was to create a language that could be used to program consumer electronic devices, such as televisions and toasters, which was a groundbreaking concept at the time. The motivation behind Java was, in essence, to create a language that was universal, efficient, and adaptable to the rapidly changing technological landscape. And thus Java was born, ready to revolutionize the programming landscape. Java arrived with a bang, bringing with it some revolutionary concepts. Let's unpack some of the key buzzwords associated with Java. First off, object-oriented. This means Java uses objects, which are instances of classes, to perform tasks. These objects make it easier to build and manage complex systems. Next, we have platform independent. This means Java can run on any device or operating system that has a Java runtime environment, making it incredibly versatile. Then there's secure. Java was designed with security in mind, offering features like bytecode verification and mandatory exception handling. This makes it a reliable choice for developing applications where security is a priority. Last but not least, we have robust. Java's robustness comes from its strong memory management, exception handling, and type-checking mechanisms, which help prevent errors and enhance the stability of your code. These buzzwords aren't just hype, they're the pillars that have made Java what it is today. Now, let's delve into the rich history of Java. Java's journey began in the early 90s when a team led by James Gosling at Sun Microsystems embarked on a mission to create a new language that could be used in digital devices such as televisions and telephones. This team, known as the Green Team, unveiled a language initially called Oak, named after a tree outside Gosling's office. However, Oak was already a registered trademark, so the team had to come up with a new name. They settled on Java, inspired by their love for coffee from the Indonesian island of Java. In 1996, the first version of Java was released, marking the beginning of a new era in programming. Over the years, Java has undergone numerous changes and additions. The Java Community Process, JCP, was established to govern the evolution of the language through Java Specification Requests, JSRs. The Java Language Specification, JLS, was developed to specify the language, and changes to it are managed under JSR 901. In 2017, the release train was changed to one feature release every 6 months, ensuring that Java kept up with the rapidly advancing world of technology. The Java class library has also grown over the years, with new APIs being introduced and original classes deprecated. Oracle Corporation acquired Sun Microsystems in 2010, and since then, they have been providing support for certain versions of Java. Today, Java is one of the most popular programming languages in the world, used by millions of developers to build a wide range of applications. Java's evolution has been marked by significant additions and improvements. Java 5, for instance, introduced new language features and improvements to the standard libraries. Java 6 added enhancements and bug fixes, while Java 7 included new features like Lambda functions. Java 8, released in 2014, included features planned for Java 7. From a small startup to a tech giant, Java's journey has been nothing short of extraordinary.
Java's evolution hasn't stopped. It's been growing and improving with each version. Let's take a walk down memory lane and explore the significant milestones in Java's version history. We start our journey in 1996 with JDK 1.0, the very first version of Java. This was when the world was introduced to the revolutionary concept of write once, run anywhere. It was a seismic shift in the programming landscape. Fast forward to Java 5, released in 2004. It was a significant milestone, introducing new language features and enhancements to the standard libraries. It brought in generics, autoboxing and unboxing, enhanced for loops, and more. Then came Java 6 in 2006, focusing more on under-the-hood enhancements and bug fixes. It was all about improving performance, stability, and security. Java 7, launched in 2011, was a game-changer. It introduced us to new features like Lambda functions, a major leap forward in the way we write and think about code. Next stop, Java 8, which arrived in 2014. It was a major release that included features originally planned for Java 7. Java 8 brought in the much-anticipated Lambda expressions, along with functional interfaces, and the Stream API, opening up a whole new world of functional programming in Java. In September of 2017, a significant change was introduced to the release cycle, with one feature release every 6 months. This accelerated pace has led to more frequent updates and enhancements, keeping Java fresh and exciting. Most recently, we have Java 21, the latest long-term support version. It continues the tradition of bringing in new features and improvements, keeping Java relevant in today's fast-paced tech world. Each version of Java brought something new to the table, making the language more powerful and versatile. And with the commitment to continuous improvement, who knows what exciting innovations the future Java versions will bring. Understanding Java isn't complete without knowing about its runtime environment and unique language features. Let's dive into the fascinating world of Java's runtime environment first. This environment is a crucial component that brings to life the principle of write once, run anywhere. It's the stage where your Java programs perform their magic, regardless of the underlying hardware and operating system. This is possible due to the Java Virtual Machine, or JVM, which is part of the runtime environment. It acts as a kind of translator, converting the platform-independent Java bytecode into machine code that your specific computer can understand. Now let's turn our attention to some of the unique language features of Java. Java is both statically typed and dynamically typed, which means that all variable types are checked at compile time and runtime, ensuring type safety and reducing bugs. It also supports automatic memory management, freeing programmers from manually handling memory allocation and deallocation. Another notable feature is Java's support for multi-threading. This allows for the execution of multiple threads simultaneously, which is especially valuable in developing complex, high-performance applications. And then there are the features introduced in later versions of Java. For instance, Java 5 brought in autoboxing and unboxing, enhancing the language's simplicity. Java 7 introduced try with resources, improving exception handling, and Java 8 brought in Lambda expressions, enabling functional programming in Java. Each of these features, along with many others, contributes to making Java a powerful, flexible, and versatile language that's suited to a wide range of applications. The Java runtime environment and its unique language features contribute to its robustness and versatility. At heart of Java's cross-platform capabilities lies the Java Virtual Machine. This remarkable component of Java's architecture is the beating heart of its cross-platform capabilities. Imagine the Java Virtual Machine as an engine that makes everything run. When you write Java code, you're not writing instructions for your computer's processor. No, you're writing instructions for the Java Virtual Machine. This is what makes Java truly platform independent. Your Java code is compiled into bytecode, a sort of universal language that any Java virtual machine, regardless of the underlying system, can understand and execute. So whether you're running Windows, macOS, Linux, or anything else, as long as you have a Java virtual machine, your Java code will run. The Java virtual machine also takes care of memory management, ensuring efficient use of system resources. It's like having a diligent manager, ensuring everything runs smoothly behind the scenes. Remember, the Java virtual machine is not just a part of Java's architecture, it is the cornerstone that allows Java's promise of write once, run anywhere to be a reality. The Java virtual machine is the secret sauce that makes Java truly platform independent. As we conclude our journey through the world of Java, we reflect on the key points we've uncovered. We've discovered the motivation behind Java's creation, a language designed for simplicity, reliability, and efficiency. We've delved into the buzzwords that define Java, phrases like write once, run anywhere that encapsulate its power and versatility. We've traced the history of Java from its first release in 1996 through its numerous versions, each one bringing significant additions and improvements. We've explored the Java runtime environment and the language features that make Java a favorite among developers. We've also investigated the Java virtual machine, the engine that allows Java's write once, run anywhere capability, providing platform independence and boosting performance. Java's influence in the programming world is undeniable. It has shaped and continues to shape our digital world, from web services to mobile apps, from enterprise solutions to cutting-edge tech innovations. And that, dear viewers, is the story of Java, a language that continues to shape our digital world.